Okay, welcome back. So here we have Algebra 1 topic 27, Multiplication Properties of Exponents. Now with this foldable, if you print it, it should be printed on the, or you should print it front and back on the shorter side, so that way when you flip it, the words and the sections will match up with the actual problems. And when you also fold this foldable should be folded similar to a book, just like with our topic 26 foldable. But once you flip it over, there's a vertical dashed line right before it says multiplication properties of exponents, and that's where your page should stop. So it should stop there. So what I'm going to do is I'm going to break it down section by section. So there are 3 flaps on the front, and once you cut on the horizontal dashed lines, that will reveal the problems beneath that kind of are examples of it. Now our first one that we're going to do is product of powers. Now on your foldable, I believe this is actually in the bottom. It's the 3rd horizontal section. That's a mistake. It should be listed at the top because all of the example problems are actually below the top section, but we'll work with it. So our example here for product of powers. Now you guys might remember this from the topic 26, kind of when we were discovering these properties. But for product of powers, for any number a and all integers m and n, so here we're just dealing with different numbers. We have a number in the a spot, a number in the m spot, a number in the n spot. So when you have numbers that have the same base here, then you're going to add the exponents. And as a review, let's kind of identify, well, what is a base? What's an exponent? What's it called? So if we have a number, let's say we have 8 to the 4th. So right here, my base is my big number. It's 8. My exponent is my 4. And all together, both of these, this is called the power. I've got the power. And an important tip to note that if a variable does not have an exponent, a variable, or I should say your base, does not have an exponent, we're going to write a 1. Like literally the exponent will be number 1. Because we know 1 is humble. Sometimes when it's a coefficient, we don't see a 1. Same thing with exponent. Okay, so going back to product of powers. So if we have numbers that have our same base, so we have a, and a, we're going to add our exponent. So remember before how multiplication is associative and commutative, so we can flip the order as long as we're keeping that same operation of multiplication going. Our product will be the same in the end. So what I'm going to do here is I'm going to regroup my numbers. So I have my 4 and my 3, so I'm going to regroup those. So that's the same thing as 4 times 3, my first grouping. Now my next one will deal with my a, so this is my other base. So we have a to the 3rd times a squared. And then my last one is b and b to the 5th. Now notice here, b does not have an exponent, so I'm going to write a 1 in here. And if we group that, we have b to the 1st times b to the 5th. Ooh, we got all pretty colors here. Look at that. Okay, now we can simplify. So we know that 4 times 3 gives us 12. And now we have a to the 3rd times a to the 2nd. So again, we're going to add our exponents here. So a to the 3 plus 2 gives us a to the 5th. And b to the 1 plus 5 is b to the 6th. Now when we write these, we don't have to write them in parentheses. I like to do that in the beginning so it differentiates between our coefficients, our a variable, our b variable, etc., etc. But we can really just write it all smooshed together, like 12a to the 5th, b to the 6th. And that is our product of powers. Again, this should be the bottom flap of your foldable. Now what I want you to do is open up the top flap. So now we're like switching around here. Thank you for being flexible. So our first example, when you open up the top flap of your foldable, should be y times y to the 5th. So here we know that they have the same base. So we're going to add the exponents. And we don't see an exponent for our first variable. So we're going to write in a 1. So our answer is going to be y to the 1 plus 5, which is y to the 6th. Next one, we have m squared times m to the 7th. So these also have the same base. So we're going to add those exponents. So m to the 2 plus 7 is the same thing as m to the 9th power. Okay. Next, what we have, rn times rn cubed times n squared. So everywhere that I don't see a an exponent, I see a lot of variables here, I'm going to write a 1 because that is my exponent there. So when I regroup, I have my r variables here, and I'll have my n variables here. So when I rewrite it, it's going to be super handy. So we have r to the 1 plus 1 times n to the 1 plus 3 plus 2. So if we simplify this, we get r squared times n to the 1 plus 3 is 4 plus 2 is 6, n to the 6th. So my problem here is r squared n to the 6th. Moving on to the other part of that flap, we have negative 4 times x cubed times negative 5x to the 7th. So again, I want you guys to treat your variables, group them together, but also group your coefficients together. So our coefficients here, we have negative 4 and negative 5. So if we group those together, we're going to have negative 4 times negative 5. And then let's group our x's together. We have x to the 3rd times x to the 7th. So negative 4 times negative 5, and negative times a negative is a positive, so we get positive 20. And then x to the 3rd times x to the 7th. 3 plus 7 gives us x to the 10th. And that is our answer there. So what we're going to do with our next problem, we have negative 3j squared k to the 4th times 2j k to the 6th. So let's regroup our coefficients together. We have negative 3 times 2. And then our j, let's do orange. And notice here how in our second term, our second factor here, this is j to the 1st because it doesn't have an exponent. So if we're going to group this together, we have j squared times j to the 1st. And then our last one, we have k to the 4th, k to the 6th. So we get k to the 4th times k to the 6th. So now we can simplify. So negative 3 times 2, negative times a positive is going to be negative 6. J to the 1st times, j squared times j to the 1st. It's going to be j to the 3rd. And k to the 4th times k to the 6th is k to the 10th. And there is your answer there. Okay, that is part 1 of this foldable. This video is going to be in 3 parts, so we can break up those 3 different sections of the multiplication properties of the foldable.